Podcast is now starting. All attendees are in listen-only mode.
Hello, this is Brian Cox from the Bioenergy Association. I'd like to welcome you to this webinar this afternoon. It's part of a series of webinars that we host. We try to do 1 or 2 a month to try and help information out to people who need it, and to be able to ensure that people have good information that's accurate and up to date. It's a fast-moving world out there, and what we're finding is that keeping up to date is critical. We're also getting a lot of examples and new players coming into the market, so these webinars are proving a very effective means of being able to get information out quickly. If you're a member, that's great. If you're not a member, we would encourage you to become a member because we can only do these webinars if we have a good, strong membership. We have a lot of followers, but we need a few more members to make sure that we cover the costs and to be able to ensure that what we're doing is actually applicable to the market. Today, we're going to have Marcus Baker, who's going to talk on decarbonising heat and hot water services for small and medium applications. This is an area where New Zealand government has putting a big emphasis. The decisions announced last week in terms of the emissions reduction plan and the budget for moving the small, medium heat plant from fossil fuels to a low carbon fuel. The decisions to have government facilities no longer able to use coal, and decisions that in terms of new boilers, again, no coal. So it's a big moving argument. The program that government is running in terms of helping government facilities to transition from a fossil fuel to a low carbon fuel, electricity or biomass, shows that we need to make sure that people out there who are the decision makers are getting good advice from all of us, and that we are showing them the best. So that's why we've asked Marcus to come in today. Marcus from Eco Hot Water, and he covers a number of technologies. So he's well positioned to be able to talk about the options and to be able to show what it is about the biomass ones that make it attractive, but also to be able to talk about some of the pitfalls and issues that people need to make sure they look out. So Marcus, I'll pass this over to you.
Kia ora. Thank you, Brian. Kia ora koutou. As Brian said, I'm from Apricus Eco Hot Water and Heating, and we do pellet boilers from Aquafin in Austria. We also do CO2 hot water heat pumps with the Reclaim domestic and commercial systems. Apricus solar hot water, which is where the name comes from and where we originated a decade and a half ago. And Easy Pearl, which is a domestic pellet boiler, and then some other products like Flow Smart, which we've developed to help empower these systems and make them easier to apply. So we cover residential and commercial, and today we're going to look at small to medium. And so small to medium, I'd say, would be really, up to 0.5 megawatt, maybe at a push 1 megawatt of heat energy. So very much a large proportion of what is out there for reduction in use of fossil fuels. And we're just going to focus on pellets, because pellet boilers are one of the best drop-in replacement for fossil fuel plant, and also it's difficult to cover a whole range of technologies in such a short time. There's quite a few people here now, so we'll look at how we're going to go through it. We're just going to start a little bit wider and then move through the tower of pellets, breaking free from fossil fuels, and so on. Just trying not to make this too difficult for everyone to follow. So if we're just thinking about the life, the universe and everything, what we're facing is a pretty historic time, and we need to be looking very seriously at how we deal with it. So we could do without seeing that in our cities and towns too often, and so the imperative for moving away from fossil fuels is essential. So just a quick question. if everyone can have a quick think about where almost all of the energy from that's available, I should say, on this earth comes from, what would be the source that would spring to mind for you? Hopefully, a large portion of you thought of Ra, the sun, the ultimate source of energy in this world, and really how we harvest and get that energy comes down to the other factor, which is time. So fossil fuels are exactly that. They are fossilized sunlight absorbed by biomass and then buried under the ground millions of years ago, and they've slowly become cooked into a fossil fuel. So a very concentrated form of solar energy that took a few million years to evolve or develop, and then has been stored underground. But nowadays we've got slightly less patience than we used to have, and so if we said that we need millions of years to develop a fuel source, most people would just become a little bit impatient and probably cold as well. So we can use a more real-time source of energy, and that's biomass, which is still absorbing solar energy, and it's still sequestering it and storing it up in a battery, also known as carbon, or carbohydrates, and mainly in the form of wood. And that's what can provide us with our fuel today. So it's a form of solar energy. It's just that it's slightly less time intensive than a fossil fuel. So this is a really good way for us to power our economy from now on. So we've dealt with these. So now let's look through the tower of pellets. So what are pellets? For any of you who don't know already, it's 100% renewable and affordable fuel. In New Zealand, it's made exclusively from waste wood, sawdust, and post-harvest forest residue. So we're not going and chopping down trees. There is some places where that does happen, and it's obviously not an appropriate use unless you are planting new trees, of course. And maybe at some point we'll decide that sending untreated green logs overseas could be better meeting our needs in this country. But at the moment, we're very much within the diversion of wood waste from landfill and forest residues. And just to be really clear, if you leave wood waste in landfill or you leave forest residues on the ground, they will decompose either anaerobically or aerobically, depending on the situation. But essentially, they decompose sooner or later and release their carbon back into the atmosphere as the respiration of the beings that are decomposing them or their bodies, and then the cycle continues, and it's called a cycle for a reason. And so we're keeping that carbon moving around in the system. So it's a critical difference between fossil fuels and renewable biofuels is that it's current account carbon. It's carbon that's already in the system, and it's just going to keep cycling. We're not drawing carbon from the Earth's crust and re-injecting into the atmosphere after it's been stored away for millions of years. So yes, we are setting fire to something. Yes, it has carbon in it, but it's got the lowest carbon emissions of any fuel in New Zealand at 0.003 kilograms of CO2 per kilowatt hour. And that's because the carbon in the fuel is accounted for through biological process and through the carbon accounting. So the only carbon price essentially that we're paying is for the manufacture and transport of the fuel. That's the very nature of biomass and keeping things in the current account and keeping it in the carbon cycle. So it's a direct replacement for fossil fuels for space heating and domestic hot water process heat. And there's an enormous potential for us to use unused wood waste in this country. Every year we're sending 250,000 tonnes to municipal landfills. So those are ones that we have a relative amount of information data on. Anyone from MFE here, please note that we can have much better data on this kind of information, and I think you're working on that. But also, as an estimate, and it is an estimate because these are commercial private landlords, landfills, which aren't council controlled. We're sending about 1.2 million tonnes of wood waste every year to landfill, which could all be used as a fuel. And then there's post-harvest forest residues. So just to give you a comparison, if we're using a pellet boiler, the wood pellets, let's just say it's the base case. So That's what we're starting from. If you're using a gas boiler, either natural gas or LPG, you're looking at a 99% reduction in the CO2 intensity if you're replacing it with wood pellets. Diesel, also 99%. Coal, a 99% reduction in CO2 intensity. And even a heat pump. So heat pumps are very useful and they're very good at energy efficiency technology because you get a multiplier, but you're still using electricity. In a small number of circumstances, we might be able to provide that electricity in real time with PV, but it's a relatively small number of circumstances, and especially when we're talking about the kind of energy intensity for heating and hot water, it's very unlikely. So we have some fossil fuel and emissions embedded in our electricity grid, albeit a really renewable grid, but because of that incredibly low impact of wood pellets, even a heat pump and a coefficient of performance of 3, so you're getting 3 times as much heat energy out as electricity in, it's still a 91% reduction in carbon intensity when you replace that or use a pellet boiler in place of a heat pump. So it's not to say that a heat pump hasn't got a place, but it's not quite as clear cut from a carbon perspective as maybe indicated sometimes. And these are all numbers that are just taken from the Ministry for Environment's emissions factor database. So you can all look this up and do the calculations. So let's have a look at the cost as well. I did a bit of a look around at what pricing we're getting from the suppliers of pellets in this country, because presumably if it's incredibly low carbon, it must be extremely expensive. Otherwise, why are we not using this far more frequently? So that gives you a reasonable spread across the country. And then if we compare it to fossil fuels also this month, for indicative figures nationwide, it's slightly harder to get their figures because generally fossil fuel companies tend to be a lot more tight-lipped about what they're going to charge people. But a figure that I got yesterday on diesel, for if you were to buy 500,000 litres of diesel a year, it was going to cost you about $2 a litre. So that's 280% more expensive than pellets, up to 280%. And at most it's 100% more expensive. Natural gas, 11 cents a kilowatt hour. That's pretty average nowadays for a commercial tariff. There's could be cheaper. There's definitely more expensive, but it's 160% more expensive than pellets. And then LPG, if we're talking about $105 for a 45 kg bottle, which is generally about cooey, you might get a bit less if you've got one of those massive LPG stores, the 200 kilo ones, but then you've also got some serious risk associated with that around explosive gas, and you've got to have certification every year, which I'm not including the cost of. At 17 cents a kilowatt hour, that's up to 240% more expensive than pellets. So it's low carbon and it's affordable. So it must be really difficult to use. But what we're finding is that the prices are really stable because it's made from waste materials. And the suppliers are offering 10-year price and supply contracts. So Aswood in Nelson are doing about 20 to 30,000 tonnes a year, and they're expanding. Niagara in Invercargill, they're about to expand in the next year up to 90,000 tonnes. And that coverage map is probably dated now. I would imagine that they will be looking to expand their reach at 90,000 tonnes a year. They're currently not manufacturing, but they have in the past manufactured maybe 20 or 30,000 tonnes as well. Nature's Flame in Topor are doing 120, they're about 100,000 tonnes a year now, but they're going up to 120 or so, and then they've got plans to double again. And they've recently been taken over by Tally's group and come under the Open Country Dairy. So yeah, there's a lot of companies that are saying, okay, well, we can see what's the writing on the wall. Let's secure these fuel development opportunities. And Waipapa Pine in Whangarei, which is an interesting small player, but a lot of opportunity because they are just above Auckland, and there's a lot of wood waste that comes out of Auckland. So the delivery of pellets is obviously an important aspect because unlike gas or electricity, it doesn't come down lines and pipes. So it does have to be moved around like diesel and LPG and coal. So there are blower trucks available throughout the North Island, and I'll show you what a blower truck means in a minute. And then increasingly, we're getting them available on South Island, and the more pellet uptake that there is, the easier the distribution is going to be because of the volumes game. And generally in the South Island, you've got elevator and auger trucks delivering. So I'd say to people, it's about the same frequency and disruption as an LPG or diesel truck delivery, but it's a much less frequent visit than a rubbish truck. So if we're just thinking about disturbance or anything like that. And the bigger your store is, the less that you need to get delivered. So I want to break free now. So let's have a quick look. This is how the excuse the noise, sorry, I should have warned you. It's a bit noisy. That's the compressor, the compressor on the truck. So as you can see, truck turns up, tips up to make gravity do its job, and then there's a blower at the back and a hose. That hose could be up to 20 meters long, and it's blowing, in this case, into an Okefenn flex silo. So we'll have a look at these flex silos. So it's a really convenient way of storing pellets. When they're empty, they're all closed up so that you get a sloping floor, so that you get the maximum amount of pellet coming out of that bag. And then when it's empty, it's all puffed up like a big marshmallow, and it's full of pellets, and it gets blasted with the air. And so when it comes to storage, we've developed an outdoor storage system, because not everyone has a space for one of these. And so you can just put a little frame around it, put it on a little wee concrete pad, and then put a cladding, essentially, and you end up with this on the outside of the building, or something that resembles that. So an example of that is what we're doing currently at the Victoria Esplanade in Palmerston North. So for the City Council, there's a boiler at the Esplanade that's keeping that mower, I guess, warm. And they've got a 150 kilowatt gas boiler, which is a bit sad, and it needs to be replaced, really, as much as anything else for the age, but for decarbonisation. And so a direct replacement, and at the moment it's emitting about 31,500 kilos, so 31.5 tons of CO2 a year. And we've got 130 kilowatt Okefenn pellet boiler. That's not, you probably note that that's a slightly different looking plant room than this one, but it's what it will look like, at least in terms of the boiler, when it's in. And it will be in exactly the same place, but because the pellets don't come in a tube from the ground, then we do need to put a store in place. So one of those external flex silos that you saw will be about 10 meters away in a clad enclosure, and we'll have carbon emissions of 475 kilos, so a half a ton a year, so a 98.5% reduction in the CO2 intensity of that site. So you can enjoy the plants that have come from tropical places and know that their habitat is hopefully going to be protected a bit more. And so just to give you an indication, because I think it's important to get down to brass tacks sometimes, that's looking to be about $160,000 installed, including building works, to construct the structure in which the pellet store is housed next to the building. And so just to give you an idea, the pellet boiler is approximately 2.2 meters deep and 3 meters wide. That's including all of the clearances needed for the boiler. So that's not just the boiler. That's butted up against the wall on either side, and you need to have some space in front. But then the flex silo is 2.6 meters by 2.6 meters, and that's going to store 8 tons or 41 megawatt hours of heat energy, if that is useful meaning. And they can be up to 25 meters apart, and they can be up to 6 meters of height difference. So they don't have to be side by side. And we've got to think in these more flexible terms when we're replacing fossil fuels, because fossil fuels, there's a reason that we've got this incredible infrastructure in the country, or in the world, because fossil fuels are extremely energy dense, and they're very easy to move around, and they're very, very useful, but they come with an incredible penalty to pay at the end. So Now we're wanting to have a similar lifestyle and not have much difference at all in how it performs, and we're able to because of the development of these technologies. But we need to be a bit more flexible in our thinking, because sometimes it was not going to line up exactly as a fossil fuel boiler has, but we can get very close. So just to give you an idea for a site like that, and if you've got something similar, I know that we're working on a number of other sites that have got, there's hundreds, thousands of boilers out there of that size that can be very easily replaced with pellets for not a great deal of money, and then be saving a great deal of money on the running costs, but also on the carbon. So all of the price differences I've shown so far, they don't include the additional cost of carbon if you're an organisation that's going to be faced with that come next year or 2025, depending on when your time frame is for your organisation. So just to give you another idea, another design that we've got, this is the central building for a retirement village. And if we just zoom in on it, it's under construction at the moment. We've got a 8-story building, including the two basement levels. And so in the sub-basement level 1, there's going to be a couple of these 8-ton bulk store flex silo pellet stores. And then basement level 2, there'll be a 130 kilowatt pellet boiler with automatic transfer between the two. And so that's about 20 meters away and about 4 meters probably of elevation or so. And in ground floor, we're going to have deliveries for the blower truck to connect to. So there's a permanent line, you could say, that goes from a service bay wall down to the sub-basement to fill those bags up. And they'll be in place, they'll be filled up with pellets, and then they'll automatically transfer again using air conveying, blowing, from the bags to the boiler. And then up, oh, it's disappearing, wrong way. So it's 20 meters from the ground floor to there. And then up on the 6th story, we've got the flue terminating at the roof. So it's a really, if you think a bit creatively and are able to work through how we can do things, it's all very viable. And this is going to do all of the domestic hot water and for this centralized service building for a retirement village. And also I think we're heating the pool now, and there's some heat going into the HVAC system around the pool. So it sort of changes reasonably dynamically, but there's plenty of energy going into the building for their needs. So that's a tower of poo, the tower of pellets, sorry. And so now we'll look at how we can break free from fossil fuels. So I just thought that there's some important questions to ask when you are looking to switch from fossil fuels. And one of the first and most important is, how much heat do you actually need? And what energy efficiency gains can be made in anticipation and also in parallel to this change? Because existing fossil fuel boilers are very frequently oversized, often by 100% or more, generally because they're pretty cheap to install, and they're often connected to pretty poorly performing systems. So it's really important to actually look at what the requirements are, not just what's in there at the moment. And then we look at a cascade. We'll come into a cascade in a sec, but can it cover redundancy? So often you have 2 boilers, a duty and standby, and that's again because of low cost. But if we're going to have cascades of boilers, so multiple boilers, they have inherent redundancy. So can we avoid having the traditional approach of duty and standby and all of that, the cost associated with that? How is the heat load spread out? How concentrated is it? Can it be flattened? Can we flatten the curve like we did with COVID, but with heat? So by having a bit of storage to help lessen the impact at one particular time, or by some control. Heat pellet boilers can definitely do both scenarios, can be very peaky or flattened, but the boiler size and the complete system or design will vary quite a lot on the nature. And in general, if we can flatten off the curve, it's going to be cheaper to install and more efficient to run. And that's across the board. That's not just pellets, that's all renewable technologies. And then what's the site-specific balance between the space available for pellet fuel storage and the optimum size and frequency of fuel deliveries and the resilience that you get. Because don't forget, the flip side to having to have fuel deliveries is a great deal of resilience, because if there's a blockage, if there's a delay, if there's something that's impacting on energy getting to the building, if you've already got a big store of your energy there and you always have a certain tonnage that's maintained and you just top it up once it gets to that level, you've got amazing resilience. And in our current world, resilience is something that is going to be increasingly valued. So more storage does equal more space, but it reduces your cost of freight relative to the fuel. And because pellets are relatively cheap to produce and made from waste products, the freight is a really important component of the total pricing, and it gives you greater resilience. So we just have a quick look in the boilers. We're not going to look in detail, but I just want to give people who aren't familiar with the technology a quick insight. So you've got a fan up here, which is creating the suction, which brings the pellets in from our bulk store that we saw. And this is what we usually call a day hopper. It might be replenished more than once a day, but it's essentially the account that the boiler's drawing on to immediately serve its needs. And in this scenario, we've got a few back burning combustion prevention measures, which I won't go into in detail, but very happy to if anyone wants to at some point. And then the pellets come down and they're augered in through to the boiler and then combusted here. And we've got primary air coming in the bottom, secondary air coming in the top, lots of turbulence happening, lots of dwell time. So we've got really good flow. We don't have laminar flow coming through. We've got really turbulent flow. So we get really amazing heat exchange. And in the case of the Okefenn boiler, we don't have any lambda oxygen or CO sensors. We're doing it all based on temperature and airflow, which is controlled by the fans. And then at the bottom, the ash just falls out. So there's no horizontal surfaces apart from the burner plate for ash and things to get trapped on. And so it falls down into the bottom and it's augered out of this burner chamber ash collection zone into an external ash box where it can be removed. So as I said, very happy to go through a lot more detail with anyone that wants, and you can look at our website in the slides. But the critical thing to understand, the controls are on board the boiler, the fuel's on board, so this does not radiate any heat at all, because if it acted like a wood burner, everything on board would get completely fried. And the Okefenn boilers, and you'll find all the other quality pellet boiler systems, the external skin doesn't get above 30 degrees. It will not radiate heat. All of the heat goes into the water and then out to the load. So the pellets are coming in, as I said, by a vacuum suction turbine. It's actually a blower, but it causes a vacuum, brings the pellets into the day hopper. And then in the case of Okefenn, we've got this fantastic little 250 watt heating cartridge, which are with a blower fitting that brings very hot air. And so the pellets are ignited just through hot air blowing against them. And it's using, as you can see, 250 watts is nothing. And then we've got the air coming through and the multi-segment burner plate, which has got loads of different good reasons for being like that. Primary of which, it gives a little shimmy and the unburnt and partially burnt pellets start moving to the edges, get burnt as much as possible, and then fall off as ash. So there's a little animation here, just hopefully illustrates for you. You can see the pellets moving through the underfed grate and they're popping up the top like a volcano. And then here you've got a roaring fire with air coming up from below. And then up here where you can't see, maybe I don't have my pen here. So the pellets are coming in, burning. And there's also a few phases of combustion that they go through. So they get heated and there is a tiny bit of water, 8% in a pellet. And then it releases its gas and you get combustion of the gas. So up in the secondary combustion chamber up here, we're getting up to 700 degrees quite easily. And as the fuel's moving, we're not disturbing the fire bed. We're not chucking more pellets on top and breaking it up. We've got a very smooth and calm combustion process, which is what you want. And they clean themselves as well. So you're not thinking about getting in with a hearth brush every day. These are completely automatically cleaning. So they've automatically refueled themselves. They've automatically removed the ash. They're also automatically cleaning the heat exchangers that go down the body of the boiler. So you essentially you've got a very big water jacket here. You can see these kind of blue cutaways. It's showing you water all the way round, and then the business end is going on in here. It's all burning, and these are moving up and down occasionally to make sure that all the heat exchange surfaces are kept clean. And that's the ash box where you pick it up, little suitcase, open it. We'll see later how it happens. So that's just a bit about what's happening inside. They're pretty bloody whiz-bang, to coin a phrase. They're from Austria, and all the good pellet boilers that you get in New Zealand and Australia from Austria and Germany, they've led the field for a very long time. There's a little bit in Scandi, there's a bit in some of the Low Countries, but really Austria is the heart of the biomass and particularly pellet boiler industry. We will not get realistically a smaller boiler market manufacturing here. We may well have large bespoke boilers, possibly, but in the range that we're talking about here, these are essentially overgrown domestic units that are very, very well suited to small commercial applications, because you don't need a boiler person, you don't need maintenance, you don't need monitoring, you don't need to understand what's going on inside the boiler. You just need to understand, okay, I have a need for heating and hot water, and so this is how it's going to be delivered for me, and I can get on with everything else that's important to my organisation. So if we look at a Cascade, this is a 256 Cascade, and so we've got a pair of 128s, and they're pretty small space. We'll do some stuff on space in a minute. And in the Orcafen example, and many of the boilers are similar to this, you have Cascades. So single boilers will go up to 256 kilowatts, and then the pairs will go up to 0.5 megawatt, and then you can have multiples. And so it's really suitable for retrofit buildings because it's really flexible in where they can be placed, and they can be maneuvered much more easily in and out of doors and upstory plant rooms and service lifts and whatever other things that people want to throw in the path to try and make decarbonisation hard. But that really does make it a lot easier. These boilers will fit through any standard 800mm door. And then you just cascade the boilers to have a bigger system. And you've got really massive modulation range with a cascade. So, for example, with the 512 kilowatts, a 0.5 megawatt, is a significant amount of energy. We've got a modulation range from 7% of peak output to 100% of peak output. So that means it's extremely efficient to run, because it's going to run based on what is the current load. So in the middle of winter, if you need a 0.5 megawatt, great, they're going to go full noise and they're going to provide that. But then if you're doing domestic hot water and it's a warm summer's day and the water's already quite warm coming in, and you only need really to add a little bit of energy, it will go down as low as 36 kilowatts. So no bother or fuss at all for the boiler. It's not going to change anything. It's just going to make sure that they're performing at absolute ultimate efficiency all the time. Really important to understand when we're trying to apply this in a modern scenario. And it goes back to, what is your actual heat load? What is the requirement that you need? How can we make sure that we're meeting it in the most effective way? So if we look at the space required, as I said, they're pretty flexible. This is the space required, including clearances. So 130 kilowatts we saw back at Palmerston North. We've got 2.2 by 3.1 meters. Now you can just plug them together to get a 0.5 meg. And because we've included clearances, it's maybe a little bit tight. It'd be nice to have a little bit more room, but it's possible to do it in less than 4.5 meters and less than 6.5 meters. And you've got 0.5 meg there. It doesn't include the fuel store, but we'll come to that in a sec. So ash removal, this is the Netherton School in Padua. So the caretaker's just picking up the ash box, and he's very happy about being photographed. You can see, it's desperately hard work. And then he opens up the side and puts it straight onto their marakai, or, well, actually that's probably a little native planting rather than the marakai. But ash from pellets is a certified organic fertilizer. Gone are the days when you took the ash out of a coal bunker, coal boiler, and you had to dispose of it in a careful landfill because it's really toxic, nasty. This is an organic fertilizer. Put it straight on the garden, put it straight on the land, wherever you want. You get only 5 kilograms per ton of fuel, so it's going to be a rare resource, but it equates to about the same for every 5 megawatt hours of heat energy delivered by the boiler. So in most scenarios in this small to medium area, we find that people only need to empty it once every month or two. We often find that they go in much more frequently so they can get a bit extra ash for the garden. But that's all the frequency is actually required. All right, so what have we been through? I need a hero. Okay, here's a cool section. So, energy boxes. Now, we've been through plant rooms. Now, sometimes there's not enough room in a building, or you just don't want to give up the building's real estate for a plant room and it could be used for something much better. We're getting this a lot in schools. So we've developed containerized systems, and it's a pellet boiler plant room in a container, and all of the components are in there. So you've got your container, which is forming your plant room. You've got your pellet boiler or boilers. You've got fuel store. You've got automatic fuel supply, just like we saw, but in a confined space. And then it's a plug and play. So you need to provide water and power, or the flow and return connections. But apart from that, everything's inside the container ready to rock and roll. You get a really high level of cost control because we manufacture these in Rotorua. We can tell you exactly how much it's going to cost, how much it's going to cost to deliver. You've got to put 4 concrete plinths on the ground to place it. And apart from that, you're good to go. They're always consistent design delivery, so you're not relying on variances that could happen elsewise. And we've got a guarantee of workmanship, of course, because we're making them. And then they're very flexible in terms of site placement. So you can move them around on the site if you need to at any point, but also you can site them away from the main building and then just duct the power and the water out to them. They're modular and expandable, and they're, as I said, manufactured in Rotorua. So we have a little bit of an explore. This is 130 kilowatt in a single 20-foot high cube container. So high cube meaning 2.7 meter stud, essentially 2.7 meter tall. It's got 130 kilowatt boiler, as it says on the tin, and it stores also 7 tons of pellets, so up to 36 megawatt hours of heat energy stored, ready for you to utilize. It's plug and play, so you can see, Brian asked me to highlight this for you guys. Here, that's where the pellets are delivered. So the truck just rocks up and they get blown into the back, which we'll see in a sec. And here is where the connections are to the heating flow and return, or domestic hot water flow and return via a buffer or cylinder, and they can just go straight out the wall or up through the roof or down through the floor, and they're reversible, so there's actually a set at the other end, and of course you've got the boilers, the ash bin, the pellet feed, and they come with a COC pre-wired ready to just plug in and go. Oh, I need to get rid of that. So you can see into the back here, you've got the flow and return on the left-hand side, and they're double ported. So if you want to come out the other end and then just go straight through the wall of the container, it might be easier to do. And it's only a steel wall, so it's easy enough to drill through and weatherproof. We've got a ladder to access the pellet store at the back. And then a bit more detail, you can see inside here the boilers, the controls, each one's individually controlled, but there is a master and the slave and some relief. And then generally, normally the flue is just going to go straight up from here. Maybe if you can't see my pointer, the flue goes straight up from here, but we haven't fitted that one yet. It's ready for transport. And just sneaking in, you can see down here the feed from the bunker. So this plywood wall is taking the place of a bulkhead wall, and that is where the pellets are stored behind there. And we're taking up half the container, and we've got 7 tons. The nice thing is that the builder can be right next to the building. The container, the energy box, can be right next to the building if you have the room and it's convenient, or it can be quite a distance away. So we're looking at a number of sites where it'd be more convenient for us to have it at a bit of a distance for one reason or another. And so then you just run some underground or overground services to the container, and off you go. These are a direct connection. So someone's asked, can they connect to existing hot water pipes? Yes. The Orca-Fen boilers are quite unique in they don't require any buffering. So in most of the schools where we're installing, for example, they can be connected directly to the hot water distribution system. So they cannot take potable water. No boiler will take potable water. So you would have to have a cylinder if you're doing domestic hot water, and that has a coil inside it to transfer the heat, or an external plate heat exchanger. But if it's circulating water in a heating system that's going into radiators or underfloor or any other kind of emitter, air handlers, fan coil units, whatever, then it just goes straight out of the boiler and round the circuit. What happens when there's a power cut? Then your heating stops, and it will start again when the power comes back on again. So the other thing that I think is really nice with these energy boxes is that they don't have to be a boring old container. So this is the install at the University of Waikato in Hamilton. And so they've done a wonderful job of really making this a beautiful piece of structure that's done by the same artist who did this huge mural. And they decided at the university that it'd be much better to make a real impression with the energy box than to leave it as a tag of paradise. And I think you'll agree it looks fantastic. This is a direct connection to the hot water cylinders, as I say, through a coil in the building, and also the central heating. So it's replacing a gas boiler and 2 gas hot water cylinders. And this one energy box, once fully utilized, would be able to heat 4 buildings in its proximity. And it includes a fuel store, and on the current consumption, we'd be looking at a refuel every 6 months or so. So I'll get to your questions in a sec. The other way, as we start expanding, we can put a couple more in here. So now we've got 2 20-foot containers. We've got 256 kilowatts in this container, and we've got some fuel store in this container. And so we've got up to 107 megawatt hours of fuel stored in here, and they can be side by side, end to end, even stacked if you want to do it. You'd actually put the boilers on top of the fuel store because they're lighter than the fuel store, and then you'd have some steps going up to it, probably reverse it, put the steps on the back, as it were. A bit more cost, but if you're very space constrained or want to particularly have a vertical alignment, then that can be done. The other thing is, by containerizing the fuel store, it can be used not only with another container for the energy box combo, it can be used when you've got limited room in the plant room for fuel. So we saw earlier that at the Palmerston North City Council, we've got the boiler in the plant room. There's not enough room for the fuel store, so we've put that outside in a separate enclosure. But there's a quite small load. They didn't have enough room, didn't particularly want a container. That's not a problem. We can do it that way. If there is a bit more load and there's space for a container, then this can be combined just as well with a plant room install. Because we can go 25 meters from the boilers, those vacuum hoses that we saw that go into the top of the boiler can transfer the fuel from this to the boiler inside the building. So you've got some penetration through the wall, but they can be easily flashed, and detailing under E2. They don't pose a fire risk particularly because pellets won't ignite in the same way that gas or fuel will, and there can be auto closing wall penetration kits as well, so it locks it closed if there's a fire. And you get a really good capacity of fuel storage, meaning that you get good resilience and low cost of fuel. So these hybrid systems, they're important when we look at how we detail the actual application of renewables going forward. So where are we up to now? All right, doggies in windows, how much? So we looked at the Palmerston North example, and that was 130 kilowatts with an external pellet store, and we said that it was about 160,000 installed, finished, including building works. Now, if we look at what we can do with a 20-foot container, we can go up to 130 kilowatts of output in one container. and including the fuel store already plug and play, no need for buffering. Just put the flow and return pipework out there and off it goes. So it's a direct connect. We don't need mega amounts of space. It often will not require building consent. In fact, I'd say almost always wouldn't, because it can come under Schedule 1 exemption as a dedicated plant room, as a pre-engineered structure that's got almost no attendance in it, or permanent, permanent population. And in most areas, it's a permitted activity under their regional plan airshed, because it's got limited output. And if we're just looking at the energy box, so we've got 3 models in this region of 20-foot container with from 64 up to 130 kilowatts. The reason there's 2 130 kilowatts is that we've got different storage capacities depending on the arrangement. And with less storage, of course, you've got a bit more room in the container for other system components. So maybe we could squeeze a heat exchanger in there if that was what was required, or some more system pumps. We're not going to get a buffer in there. We could with 64 kilowatts, but nothing more than that. And here's some pricing to give you an idea. So 130 kilowatts with the most storage, so 36 megawatt hours of storage, and the most resilient. So you've got the 2 independently operating boilers, still fully cascaded, still fully managed with balance duty, but they can operate independently. $150,000 ex Rotterdam. I don't think it's ridiculous for the delivery of that amount of renewable energy. And then once we move up a scale, we need to go to 2 20-foot containers or a 40. We find 20 is easier to manage, but it's very much site preference led. And in 2, we can go up to 256 kilowatts, as you saw the 2 diagrams, and 20 tons of fuel. And then you've got respective pricing along the side. So I'm not trying to sell you something here. I just think it's quite important to have an understanding of what's available and what the indicative cost is for a New Zealand constructed system that's using the best boilers and materials from around the world, but trying to apply a little bit of Kiwi ingenuity and dynamic thinking to the problems that we face in this country specifically. So you can just keep adding more. Essentially it's an entirely modular system. We're working on a project at the moment with a large organization where we would potentially do 1 megawatt in containers, with the ability, when they're not going to use that site in the same way that they're using it now, just to pull it all apart and take them into 256 kilowatt modules and send them elsewhere to their estate to use in other places in the country. So this is a beauty about modularity. These boilers are going to be lasting 25 to 30 years, and there's not every site that can guarantee their consistent operation during that time frame. So we can say, okay, invest it, but then if you need to, just pull it apart and it's all going to work like a Lego system in its separate blocks. And so on. We're going from 192 kilowatts up to half a meg, and from 225 up to 500,000, say. And as we start getting to bigger ones, it probably makes more sense to start cladding them and fitting some false roofing. But we're talking about a non-structural, non-load-bearing cladding that really wouldn't add a great deal of cost to the structure. So we've been through a few bits here. Now onto the important ABBA punchline. What's happening out there? So the government have invested $4.5 billion in the budget this month under the Climate Emergency Response Fund, and ECA's responsible for a good chunk of that. And they've got the GIDI fund. So anybody out there who's in industry, that's a lovely honey pot to look at to reduce your carbon intensity. And I know there'll be another round coming out shortly. The State Sector Decarbonisation Fund, for those of you who are working in government, there's 220 million, and we're helping to deliver a large chunk of that through the coal boiler replacement program, which they've got $55 million earmarked for. There are also Crown loans, which often get forgotten about, but are a zero interest way of borrowing money and often can enable you to repay based on the savings. Now, given the price of diesel, particularly now, and gas, the savings from a pellet system could well pay for itself in the same period that a Crown loan is going to be eligible for you as a state sector entity. And then ECA also do the Energy Transition Accelerator Programme that I know a number of you are on. There's the New Zealand Green Investment Finance, and it's lovely to see maybe they've attended. There were some people who registered from that. They've got a $400 million honeypot. As of last year, that's probably grown by now, or maybe it's shrunk because they've invested it. Well, what's interesting for that organisation is that they've looked at very large impact investments, but there's a very limited menu of impact investments in this country. And not trying to tell you how to do your job, but there could be a way of aggregating multiple savings opportunities into more of a fund scenario. And so, of course, they've got to have a payback because you're an investment finance vehicle, not just a doling out of cash. But as we've demonstrated, as I've demonstrated, as the market is demonstrating right now, the transition from fossil fuels is becoming increasingly self-funding because of the difference in cost. There are also commercial operators. One that we work with is called Energy Ease. They pay for the plant replacement and energy efficiency under finance programs. There's no money up front most of the time. They go up to 10-year terms. They'll finance from as small as $3,000 up to $5 million in project financing. And that will include installation, commissioning, turnkey project. Aussie firm, primarily focused in Australia on PV, but they do heat plant as well. And they do energy efficiency measures, so maybe you can bundle up. And I'd also encourage people to speak to their main financial provider, because these guys are talking a fantastic talk, especially Kiwi Bank and ASB say they're one step ahead. Well, let's ask them to put their money where their money is and see if they can fund these activities. So if you're doing business with the organisations, then they should be supporting you back to be resilient in the future. So that's it from me. There's some questions that have come through. I think I've dealt with one about the power cut. Just try and make this a bit bigger. Yes, we'll share the screen, the slide, sorry, Mads. Price and emissions comparisons of coal versus wood pellet and also waste oil. I don't know very much about waste oil, I have to say. I don't know how clean it is to burn and whether burning it in a low temperature combustion environment is the best thing to do in terms of emissions. But comparable costs for coal, interestingly, I've just done this with some schools that we've been working with. And once you factor in the efficiency gains, because often coal boilers are quite old and not particularly efficient, and the quality of coal coming through in this country is dropping rapidly, they are spending pretty much identical sums between the pellets and the coal. Essentially they're burning much less fuel, which is more expensive than coal. Let's not be unrealistic. Coal is very cheap and unrealistically cheap, but the net total cost to them is remaining very static. I've answered that. What's if there's a problem? Registered technician all over the country. Yes, absolutely, Dina. That's really important to us as an organisation. So we've got partners in Auckland, Hamilton, Tauranga, Rotorua, New Plymouth, Palmerston North, Wellington, Nelson, Christchurch, Dunedin, Invercargill. So not in every single town, but close enough to be able to capture the needs of the community with a couple of hours drive. Can you please explain a little bit more about how the minus 91% reduction of carbon emissions was reached compared to heat pumps? Yeah, no worries, Jessica. So, how do I do that most easily? I don't think I can bring up other stuff particularly easily. So, everything has an emissions factor. So, if you look on the Ministry of Environment page and search for emissions factors, you can download the current New Zealand emissions factors, and these are what we use to report to the IPPC. And so, globally, we have to have agreed norms for how we measure emissions, and it's like financial accounting, that there are certain ways that you decide. And so in New Zealand, we have emissions factors for all our main energy sources. For electricity, it's 0.0977, but when you include losses in lines, it's about 0.1. So for every kilowatt hour of electricity that we use, you're emitting 0.1 of a kilo of carbon dioxide equivalent. For gas, it's about 0.2 for natural gas, and for LPG, it's like 0.22, and for coal, 0.25. So the carbon intensity increases. So let's just say 0.1, or for maybe just to make the maths easy, for every 10 kilowatt hours you use, you're emitting 1 kilo of carbon dioxide equivalent into the atmosphere. So with a heat pump, you're using 1 unit of electricity, or let's use the math. We're using 10 units of electricity, and we're going to get 30 units of heat energy out. That's your coefficient of performance, is 3 to 1. Even an amazingly performing heat pump might get 5 to 1, but relatively rare, and you need a ground source and blah, blah, blah. We're just talking about air source heat pumps. 3 to 1's a fairly good number. I'd actually suggest in a lot of circumstances it's generous. But anyway, so 10 units of electricity, 30 units of heat. 10 units of electricity, 1 kilo of carbon dioxide equivalent. If you get 10 units of electricity, I'm getting all tangled up. So one kilogram of CO2 equivalent. But because we've got this multiplier, you could divide that by 3, because you've got 30 units of heat energy out. So it becomes 0.3 of a kilogram of CO2. If you're using wood pellets, that 10 units of energy is going to be costing you in carbon terms 0.006 kilograms, 0.03 kilograms. So it's a magnitude of 10. I probably need to send you a spreadsheet. It's a little bit difficult to describe without a whiteboard or something. But have a look at the fundamental thing you need to look at is the Ministry for Environment's emissions factors. It's got a emission it's actually per kilogram of industrial wood, which is what pellets come under. And for every kilogram of wood you burn, you get 5.1 kilowatt hours of energy. Sorry, a bit of a rabbit hole. I'll try and get in touch with you separately, Jessica, or get in touch with me. What about the recording? Yeah, it's going to be shared. What is the electrical power required to operate 130 kilowatts setting at full power? So, Robert, sorry, I'll just say it a bit more slowly. Electrical power. So for a Orca-Fen boiler, the biggest draw is up here, the fan unit that's going to pull the pellets into the boiler. So if in the worst case scenario, you've got 2 of those fan units, or not worst case, but the most resilient scenario, you've got 2 of those fans, then at any one time it could be drawing 2.5 kilowatts of electricity, but that's only for about 5 minutes every day, maybe twice a day, if it's using a load of fuel, because that transfers all the fuel. The rest of the time, and then when it heats, so we looked at the beginning, when it starts, it uses, here we go, so here's the fan, 1.3 kilowatts, but only for 5 minutes once a day. And then the igniter in here, the igniter, that's 250 watts. But again, that's for a few minutes when it first starts. And if it's got multiple starts in a day, it won't even use that. It will just use air and residual heat. So when it's ticking, what I'm trying to say, when it's ticking over, it's using about 300 to 400 watts. So half a kilowatt. So we've got half a kilowatt here, and we've got 130 kilowatts here. So actually, if you want to work out the COP, we've got 130 divided by 0.5, so we've got a COP of 260. So that's a really important thing to understand. Heat pumps are really efficient, but you're going to get a COP of about 3 or 4. A pellet boiler, if we look at energy in, energy out, from an electricity point of view, just because of course there's energy in the pellets, but from an electricity point of view, we've got a COP of 260, more or less. I hope it makes sense. Rick, hi Rick. Okay, they're coming, Rick, they're coming. Who else? Catherine, in your calculation of emissions from your wood boiler system, have you included emissions from transport truck? Yes. So when you look at the emissions for industrial wood under the MFE guidance I'm encouraging you to go to, that is the vast majority of what those embedded emissions are. So there's a small portion from the manufacturer of the pellets, but I mean, in reality, Nature's Flame used waste geothermal heat from Genesis before it's re-injected into the Wairaki well. Nature's Flame will use waste wood to dry anything. Niagara will also be using waste wood to dry anything. So from a drying perspective, they're actually pretty much carbon neutral. And so it's just the transportation. So that's where the embodied carbon actually comes from. Are there plans of expanding the market of this product beyond New Zealand? Ah, hello from Zambia, sorry. Cool. Well, get in touch with Orcafen. They're in Austria and they sell boilers all over the world. We're a pretty tiny market, in fact, and so I'm sure the size of the country of Zambia, although your heating needs will be a lot less than we have, there'd be plenty of opportunity. And I guess as much as anything else, because there's quite a few people listening from Aussie, it's about bringing the whole thing together, because without the boilers, you can't burn the fuel, but without the fuel, you can't use the boilers. So there is a coming together of the two sides. We're just incredibly lucky in New Zealand that we've got a very large and mature pellet manufacturing market, because as usual, we were exporting it. So as with lots of good things that come out of New Zealand, we send them overseas. And now we're starting to able to really reap the rewards of having that fantastically mature market in this country compared to our Aussie partners, who I think, unfortunately, you've got a little way to go before there's such a good distribution of pellets in the country. So I hope that was helpful. It's a bit of a whistle-stop tour, and there's quite a lot quite a lot to cover. Those are my contact details. If you want to be in touch, please do. When I've done these webinars before, it's sparked off some really interesting conversations after them. But yeah, by all means, get in touch and let's try and make this a better world for the future, because that's all I'm really here for. And that's me.
Thanks, Marcus. That's great. So if there's any more questions, click them in quick. Or if you do want to make a comment, put your hand up quick. Otherwise, we'll close off now. It's after 3 o'clock, and we plan to try and keep these to an hour if we can. So it's been a great coverage, Marcus, and I think it really shows the maturity that's happening in the heating market now, the biomass heating market, and some of the strengths that the pellets particularly bring to the market, where you can bring your fuel in on a truck, blow it into a store, and which is easy to build. Gone are the days when you had to build a large storage bunker with lots of concrete, timber, or whatever, where you can have those fabric ones. A lot of the similar advantages in terms of chip, but what you've outlined for the pellets, I think, shows the strength of why moving to biomass energy is just so much easier, and why they're now becoming an off-the-shelf product particularly with your containers and your being able to construct them, move them in, and you don't have big construction times, don't have big venting problems. So we're making energy very easy. And the advantage also is where you're connecting into an existing hot water system, where it's only a matter of running a few pipes between the old connection and the new connection. So I think that's really good. The webinar will be put on our website, as are all of our webinars. You'll get a note later today giving you the link for that. They're in open access for a set time, and then they will move into the Bioenergy Knowledge Centre, where they are still accessible, but that's where it's open access for members. If you're not a member, then you need to contact us. But the avenue is we're trying to build up a repository of information so that people can go back to them and check out some aspect. And if you look at the Bioenergy Knowledge Centre now, after we've got 20 years of webinars and conference presentations, documents, etc., that's a wealth of information, and it should be able to answer every question you've got. However, if you've got more questions or you've got more topics that you'd like us to address, we're keen to hear from you. If you've got a topic that you would like to speak on yourself, contact me. But we are keen to hear what is it that users or people most need to know about, so that we can see if we can find someone who can talk on that topic and to be able to speak for it. Our next webinar in early next month, I can't remember the date, is on short rotation crops. And so a bit of a focus we're doing at the moment is in terms of the biomass supply, reinforcing that there is adequate biomass throughout the country, that the fuel will be available for the next 30 years. There is adequate arrangements for being able to produce that from existing sources, but also the new sources that are coming onto the market, as more and more people are recognizing that there's value in biomass if you're a grower, and that there is cost savings if you're a user. So thank you very much, Marcus, and thank you again for the time. And you managed to get the record number of attendees. We had 188 registrations, which is a new record. So you did very well to do that. So thanks very much, Marcus.
Thanks, Brian. Thanks all for attending.
Right, I'm going to close the webinar off now. Thank you.